Heuristic functions in AI are rules or strategies used to guide search algorithms towards finding solutions more efficiently, especially in complex problem-solving tasks like pathfinding or game playing. They estimate the cost or distance to a goal state, helping algorithms make informed decisions about which paths to explore first. They are crucial for optimizing search algorithms like a** or minimax in various AI applications. Sure, let's take the classic example of the 8 puzzle problem. You have a 3x3 grid with 8 numbered tiles and 1 blank space. The goal is to rearrange the tiles from an arbitrary initial configuration to a predefined goal state by sliding the tiles into the blank space, one move at a time, until the tiles are ordered sequentially. Solution with explanation. 1. Initial state. You start with a scrambled configuration of the tiles, such as 1 2 3, 8 4, 7 6 5. 2. Goal state. The goal state is a specific arrangement, such as 1 2 3, 8 6 4, 7 5. 3. Heuristic function. One heuristic function commonly used for this problem is the Manhattan distance. It calculates the sum of the horizontal and vertical distances of each tile from its goal position. For example, the Manhattan distance for tile 1 in the initial state is 0, it's already in the correct position, while the Manhattan distance for tile 8 is 2, it needs to move 2 spaces horizontally and no spaces vertically to reach its goal position. 4. A** search algorithm. A** is a search algorithm that uses both the actual cost of reaching a node, known as G, and the estimated cost to reach the goal from that node, known as H. In the case of the 8 puzzle problem, the heuristic function provides the H value. A** selects the node with the lowest f is equal to G plus H value for expansion. 5. Solution process. A** starts with the initial configuration and explores possible moves by sliding tiles into the blank space. At each step, it calculates the f value for each possible move based on the current configuration and the heuristic function. It then selects the move with the lowest f value for expansion. This process continues until the goal state is reached. 6. Optimality. A** with an admissible heuristic, one that never overestimates the true cost, guarantees to find the optimal solution, i.e., the shortest sequence of moves to reach the goal state. 7. Example. A possible sequence of moves, not necessarily optimal, to reach the goal state from the initial configuration mentioned above could be 1. Move the blank space up. 2. Move the blank space left. 3. Move the blank space down. 4. Move the blank space right. This sequence would result in the goal state 1 2 3, 8 6 4, 7 5. That's a basic overview of how heuristic functions, in conjunction with A** search, can be used to solve problems efficiently in AI, such as the 8 puzzle.